Okay, so a little bit of review here for angles in standard position. It's stuff that we've learned in pre-calculus 11, but again, we will want some degree of comfort, so let's do some review. For angles in standard position really just means that we have some coordinate grid. So I will just quickly draw one. I know there's some here that already exist, but here's an x and y axis here. So if we have an x and a y axis, an angle in standard position really just means we are drawing angles starting on the x-axis and then rotating counterclockwise. So we are rotating in a particular direction. And if we stop at some point, we usually call this point that we stop the terminal arm. So if we connect the origin to this point that we stop and then just keep going, this is really what we call the terminal arm. Terminal really just means we are stopping, right? So if you are riding the bus or the SkyTrain or something, and you are at the terminus station, you are at the ending station. Just like here, we have some angle that starts on the positive x-axis. We are rotating counterclockwise. Where do we stop? We stop at what's called the terminal arm. Again, in principle, the terminal arm goes forever. It doesn't really have an end. But you could also be interested in some particular point. You could be interested in some particular point on the terminal arm, and maybe you're interested in the x and y coordinates of that point. Now, you can also go in the opposite direction. So I've stated that you have to go counterclockwise, but you could also go clockwise. You could. It's just that we would call that a negative angle. So whatever angle you have here, we would say that this is a negative angle if you are going clockwise in red here, or if you are going counterclockwise in blue, we would say that's a positive angle. And again, very, very important, notice that both of these angles in standard position, they start on the positive x-axis, and the positive x-axis in general, the positive x-axis is something that we call, if the ending arm is something that we call the terminal arm, the beginning arm is something we call the initial arm. The initial arm. It is the starting point for our angle. So we have a ending point, a terminal arm, and we have a starting point, an initial arm. So hopefully those words are clear and meaningful. And again, angles in standard position are always drawn on a coordinate grid. And this just sort of goes through all of that. And how we get positive angles and how we get negative angles and so on. Okay, so we want to sketch the following angles in standard position. So no angles in particular are written, so I've got some angles that we can try. One angle that we can try is an angle of 300 degrees. So let's say we have some angle of 300 degrees. If we want to draw an angle of 300 degrees, which quadrant will we be in? Well, if we're starting on the positive x-axis, and we know that our angle is positive, we know that we're going to be rotating counterclockwise. So we'll go at least until 90, but definitely past 90 degrees. We'll go at least until 180 degrees, but definitely past that. We'll go at least until 270 degrees, but definitely past that. How far past this angle of 270 degrees are we going to go? We're going to go 30 degrees past that. And that's roughly, maybe roughly, very roughly, 30 degrees past, past this 270 degree angle. So where we stop, that's where we can draw our terminal arm. Terminal arms start at the origin, 0, 0, and then they just go on forever. So here is my angle. This is theta. Now, now it might be useful, if especially in the beginning, to draw some reference angles. I shouldn't call them reference angles. To draw what are called the quadrantal angles, just so that you have something to reference. So here you might say that this is 0 degrees. This is 90 degrees. Here this is 180 degrees, and this is 270 degrees. And it might be more clear with these sort of quadrantal angles that I've drawn that to get to 300 degrees, you should go all the way to this quadrantal angle and then around 30 degrees past it. So there you go. That's that angle in standard position. Another angle that we can draw in standard position, I've written down, we can have negative 140 degrees. Let's do that in another color. So let's say we have negative 140 degrees. Let's draw our quadrantal angles so that we have some sense of reference here. So here this is 0 degrees. If we're going in the negative direction, then we should draw these negative quadrantal angles. So this would not be positive 90, this would be negative 90 degrees, right? Because these two axes meet at a perpendicular angle, or a right angle, which is 90 degrees. And if we keep going another 90 degrees, we would hit negative 180. And if we kept going, we would eventually hit negative 270. But we don't even need to go that far, right? We don't even need to go that far. We can simply hit 90 degrees and then go how far past 90 degrees? If we're at negative 140, we can go 50 degrees past that. So roughly 50 degrees past that. There you go. And you can draw your terminal arm starting at the origin, going through where the angle stops, and then just continuing forever. So this is your angle theta in standard position. Now, lastly, we've got another angle, and it's a funny angle. Let's do this in green. So for this angle, not really funny, haha, but funny nonetheless. Let's say we have this green angle of 470 degrees. So we've got a positive angle here, so we know we're going to be rotating counterclockwise, unlike this red angle where we were rotating clockwise. So we can draw these positive quadrantal angles here. This is 90 degrees, this is 180 degrees, this is 270 degrees. We started at 0, but we might notice that we've run out of degrees here. So first, let's just start on our initial arm, which is the positive x-axis. Let's rotate as much as we can. We've rotated as much as we can, and we've hit our maximum rotation, right? We've already rotated 360 degrees, but this is not really the maximum, right? We can go beyond 360 degrees, and we can continue. So if we just keep continuing, we'll eventually hit 90 degrees. So we've gone 90 degrees past 360, so that would be at 450 degrees. So this would be at 450 degrees at this point. And how far past this y-axis, how far past this positive y-axis do we have to go to hit 470 degrees? Well, 20 degrees. We have to go 20 degrees past there. So now I've gone 20 degrees past 450. There we go. So now I can simply just draw my terminal arm starting at the origin, going through where this angle stops. So that's my terminal arm. And this is my angle theta in green in standard position. So this is a decent example because it shows you that we can do more than one full revolution, right? For angles in standard position, you can actually do as many revolutions as you like. You can go forever if you want. You can do as many revolutions as you like, and if you stop here, then all you need to do is just count how many full revolutions you had, and then multiply that by 360, and then add whatever you went over, however many degrees you went over 360. So you can go more than 360 degrees. That is perfectly fine and perfectly allowed. Okay. So another thing we should look at is this idea of reference angles. Each of these angles in blue, red, and green that we drew, they all have reference angles. And I'll just quickly show you them. So here, this is the reference angle that would exist for our blue angle. This is the reference angle that would exist for our red angle. And this is the reference angle that would exist for our green angle. So how am I determining that? Well, for angles in standard position, the positive acute angle formed between the x-axis and the terminal arm is the reference angle. Positive acute just simply means, what does acute mean? Acute just means less than 90 degrees. So let's look at some angle of, let's look at some beginning angle. I'll just draw it in red. No, I'll start with blue, just like the previous example. So let's say we have some angle of 70 degrees. And for 70 degrees, we know we're not going to go all the way to 90 degrees. We're just going to go 20 degrees short of that. So that will roughly be angle theta. And now let's listen to the instructions for drawing an angle in standard, a reference angle for an angle in standard position. Well, you just you really just draw an angle from the terminal arm to the x-axis. So here you have your reference angle, and in this particular case, your reference angle also happens to be clearly 70 degrees. So here, if you have an angle that terminates in quadrant 1, this is quadrant 1, then your angle in standard position, is simply just going to be equal to your reference angle. This is actually a property of all angles that terminate in quadrant 1, all positive angles that terminate in quadrant 1 and don't go more than one full revolution. So in this particular case, they happen to be equal. Let's look at another case where they don't happen to be equal. So let's look at an angle of 130 degrees. So for an angle of 130 degrees, we are going to want to start on our positive x-axis as always, and we are going to want to go through 90 degrees. How many degrees are we going to go through 90 degrees? Well, 40 degrees past 90 degrees. Drawing our terminal arm here. So here's our terminal arm, and our reference angle is just going to be drawing a point on the terminal arm and then connecting it down to the closest x-axis. So here we have this acute angle. So here is our reference angle. Here is our angle in standard position. And so what is our reference angle? Well, in this particular case, we could say our reference angle, if we go from, and I'll do this in green, if we go from the positive x-axis all the way to the negative x-axis, that would be 180 degrees. And if we go all the way to 180 degrees and then simply subtract, well, let's go the opposite way. If we go all the way to 180 degrees and simply subtract, there we go, simply subtract the angle in standard position, what are we left with? Well, if we go all the way to 180 degrees and subtract the angle in standard position, we're really just left with this angle in black, this reference angle. That's all that we're really left with. So again, let's do this more algebraically. If we subtract our angle in standard position, 130 degrees, we should get, oh, I'm showing you too fast, we should get our reference angle. So this is our reference angle. It is 50 degrees in this particular case. So here, one thing we can notice is that this particular angle, its terminal arm, is in quadrant 2. And this is going to be true for all angles in standard position that end in quadrant 2. All we have to do is take our angle in standard position and subtract it from this 180 degree angle, which is the angle that we would get if we went from the positive x-axis to the negative x-axis. So this is true in general for all angles whose terminal arms end in quadrant 2, so long as they are less than 360 degrees. So I will actually write that. Theta r is really just equal to 180 degrees minus your angle in standard position, so long as your angle in standard position is less than 360 degrees and greater than 0 degrees. You could even say so long as it is less than 180 degrees, and we have this condition that the terminal arm ends in quadrant 2, so then you could even say for angles in between 90 and 180, this rule will be true. What are the conditions for this rule to be true? Well, the terminal arm has to be somewhere in the first quadrant. So you could say for this particular rule, this is actually always going to be true for your angle in standard position being less than 90 degrees and greater than 0 degrees. Okay, so there we go. So this is always how you can find your reference angle. It's just simply going to be equal to your angle in standard position, so long as you are within this domain. Okay, so let's look at another example. Let's look at an angle in standard position of 240 degrees, and let's maybe go a little bit faster here. So let's do this in green. So let's say your angle in standard position here is 240 degrees. So we are going to start on the positive x-axis. We are going to rotate past 180 degrees. How many degrees past 180 are we going to go? 60. We're going to go 60 degrees past 180. Here's the corresponding terminal arm. We want to know, so this is theta. We want to know what our reference angle is. And we can see that our reference angle, it's simply going to be this angle of 180 degrees right here, plus, or rather, how can I describe this?